Right, through this I will start the limits revision for combined maths. Already I complete 10 videos for vectors revision. That's applied maths, a big problem in essay and the structure. Here this is pure maths section, especially in the structure paper, 25 marks. So I decided to work here after some few series of videos showing many problems under limits, because this is completed by the juniors as well as the seniors, those are preparing for the exams. So I hope you will learn in the theory classes the limit idea. The approaching something becomes what? X tends to 0, x tends to pi by 2, or theta tends to 0, like that. So the main part when using the limit question, if you directly substitute the given term in the expression, it becomes one of these. There are 7 indeterminate form. There are 7 indeterminate form. Those are 0 over 0 or meaningless form. 0 over 0, you can say cut the 0, 0, answer is 1. That's a primary work, that is not a, I think that's a Facebook joke. You can't take like the infinity over infinity, one of the indeterminate form. 5 minus 5 0, 7 minus 7 0, like that. You can say infinity minus infinity 0. That was a meaningless answer. Indeterminate, you can't evaluate that. Another one, infinity multiplied by 0, meaningless form. 0 to the power 0, meaningless form. Infinity power 0, meaningless form. 1 to the power infinity, meaningless form. So these meaningless forms we are using by any other mode of theory, application, theorems to get another different answer. If you directly substitute one of these comes in a question, that's called meaningless form, cannot find a limit like that. Therefore we have a rule that I hope you learn in the theory class. Okay, in syllabus we can use, there are frequently 3 types of limits rules. Algebraically, first one is what? X to the power n minus a to the power n over x minus a. That pattern n can be a irrational, rational, integer or fraction, or negative, positive or negative, no matter. The answer is what? N a to the power n minus 1. If you directly apply x for a, what happens? 0 over 0, one of the meaningless form. That's why this theory, I hope you completed in theory class, also proved that one. You can simply prove by using factor theorem and also. And second theorem, trigonometry, we have major part 1, sine theta over theta. Theta tends to 0, answer is 1. Otherwise, if you directly substitute sine naught, sine naught is naught over naught, one of the meaningless. That's why the answer is 1. Very earlier, when double maths periods, they asked the exam to prove this. You will give 20-25 marks for that. Prove by radian measurement theta. Sine theta over theta 1. But now they won't ask the proof. Straightly one question, 25 marks problem here. Next, tan theta over theta, what is same as 1. These are the standard form. So in questions we use these things. Some problems they are, if directly implement comes this answer, you can remove the rationalize the form, irrational number, rationalize to denominator pattern, or some factorization idea. By using, we can go to the approach to a constant number. Limit can be 0, answer can be 0, answer can be infinity. Answer cannot come this pattern. But another important thing, the syllabus, limits very big theorem we have in advancement, higher mathematics, the series convergent, divergent series. Also we have the L'Hopital's rule. L'Hopital's rule in limits. But our local syllabus, we don't use it advanced level. Also there is no logarithm x or e to the power x problems, no direct issues in this problem, no direct theory we use here, but some indirectly some questions available. We'll see, I show in the future many problems. I have to work like vectors. You also I target 30 or 40 question, full exam type style problem, expecting question from start basic to high advanced type question. Okay, this is a major part we are using, right? Okay, then we'll see the question. The first problem, limit x tends to infinity 5x cube plus x square plus 2 over 1 minus x cube plus 5x. So first question, simple problem. So I am covering through this video series juniors and those preparing for the future exams, both two batch 2021 and 20, and later they can use it this whole video and any durations, no matter. Okay, so the idea, put x for infinity. If you substitute for straightly x for infinity, here infinity, 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 infinity plus infinity, infinity. Below also infinity. Infinity over infinity, one of the meaningless form. Then we have learned the theory class. If x approach to infinity, the idea is what? You need in the calculus also drawing graphs. You divide by the highest power. Divide by the highest power, denominator and numerator. Highest power is x cube. So divide by x cube, both of up and down. So limit x tends to infinity. So here 5x cube divide by x cube plus x square divide by x cube plus 2 over x cube over 1 over x cube minus x cube. Straight you can write the answer by dividing. The first problem, therefore I am showing the method and correct it. Divide up and down by x cube, numerator and denominator. So therefore limit x tends to infinity. Here what, 5x cube cancel, right? 5. This is 1 over x plus 2 over x cube over here 1 over x cube minus here 1 plus 5 over x square. Then write the infinity, direct substitute. 5. What is the number divided by infinity? 0, right? Plus the 0. Next one, 1 minus 0 here, minus 1 plus 0. We have the answer, the first question, minus 5, right? Answer is minus 5. Second question, limit x tends to infinity, x to the power 7 over 2 plus 7x 5 over 2 power minus 3 over 5x to the power 7 over 2 plus x to the power 3 over 2 plus 4. Another question, so here also once again x tends to infinity, approach to infinite. Direct substitute gives you infinity to the power any number is infinity. Numerator infinity, denominator also infinity. Therefore one of our meaningless form. Therefore use how I shown the previous problem. Divide by the highest power. So here the highest power is x to the power 3.5, is it? 7 over 2, 3.5 or 7 over 2. So best to divide up and down by that x power. So limit x tends to infinity, x to the power 7 over 2 divide by x to the power 7 over 2 plus 7x to the power 5 over 2 divide by x to the power 7 over 2 minus 3 divide by x to the power 7 over 2 over 5x to the power 7 over 2 plus 3 divide by x to the power 7 over 2, everything divide by that. X to the power 7 over 2 plus 4 over x to the power 7 over 2. Numerator, denominator divide by that. Then what is the answer? Limit x tends to infinity. Here this cancel, same one, answer is 1 here. Plus here what, 7. Here you know the bases are same and divide, subtract the power. Below the highest power 7 over 2 minus 5 over 2 is 2 over 2. That is 1. Okay. So the below x to the power 1, it means x, right? X minus here 3 to the power 3 over x to the power that. Over here 5. Now here same idea, x over, if you subtract here whatever, 2x square is it? Below 1 over x square, 1 over x square plus 4 over x to the power 7 over 2. 7 minus 3, 4, 4 divided by 2 is 2. And now apply x for infinity, 1 plus, this is 0, minus 0, here 5, everything hereafter 0. Therefore the answer 1 over 5, right? 1 over 5, this is my second limit problem, the revision limits. Also we completed this theory class of many problems. Here I try to show some different problem, not the same as now once again. Next question number 3. Third problem, limit x tends to 0, x tends to 0, 4 plus 5x over cos 3x. 4 plus 5x over cos 3x. So when the question comes, try you quickly substitute for straight, substitute, also check whether how it's one of the meaningless or any other. Put x for 0. 5 times 0 is 0, therefore 4 only. Numerator is 4. What is below? If x is 0, cos 3 times 0 is 0, cos naught is 1. Cos naught is 1. So therefore no any meaningless form, direct answer, right? So here the answer is 4 plus 0 over cos naught. You know cos naught is 1. Cos naught is 1. The answer is 4. So you have to work every type of question. Suddenly it becomes like this. Sometimes we think very huge method, but simple answer here. Next question number 4. Fourth problem. Limit x tends to 0. X tends to 0. 2 sin x minus 3 tan x. 2 sin x minus 3 tan x over 6x sin x cos x. And the question involving trigonometric limit. See what happens if you substitute x for 0. X for 0, here 0, tan naught naught, cos naught here 1, here 6, here okay. Put sin naught naught, tan naught naught. Question is 6x cos x. Cos naught is 1, here 0. 0 over 0, meaningless. They have used some any other method, factorization or dividing, something like that. We have a theory for what? Sin theta over theta, sin x over x, cos x over x, tan x over x, especially sin and tan theta over theta. Therefore here I decide, I divide up and down by x in terms of numerator, denominator, divide by x. So limit x tends to 0, 2 sin x over x minus 3 tan x over x over 6 cos x. X cancel, right? If I divide by x, x cancel. So I divide by both x. And now there's a formula. Sin x over x, x tends to 0. tan x over x, x tends to 0. Write the answer. So 2 times sin x over x, answer is 1. Okay. Minus 3 into tan theta over theta pattern, answer is 1. Below what? 6 into x for 0, cos naught is 1. Therefore the answer is it minus 1 over that 6. Minus 1 over 6. Next question number 5. Problem 5, the limits. 2 over x sine x over 5. Say limit x tends to 0. X tends to 0. So first you try to substitute. Put x for 0 sine naught. No, this is not. Here this is 2 over naught infinity. Okay. 0 into infinity. Fourth part meaningless. 0 into infinity. Okay. This is infinity. This is 0. One of the meaningless. Therefore use the form of trigonometric method. So we have the general form sine theta over theta pattern, right? Therefore limit x tends to 0. Can I write this one first? Sine x over 5 act as an angle here. Then divide by sine theta over theta. Sine 5x means below 5x. Sine 2 alpha means below 2 alpha. Therefore in this case x over 5. Right? Now see any other alteration, the extra additional term is here. This is okay. And this x, okay. And there's a 2. And this 5, additional 5, I want to remove that 5. There are 5 multiple of 5 here. Is it? Check that. 5 cancel. 2 there, x there, sine x over 5 available. That's all. If x tends to 0, we already use it. Theta 0 means 5 theta also 0. Theta by 2 also 0. So x0 means sine theta over theta form. Okay, this becomes 1. We have answer 2 over 5. This becomes 1. We have an answer 2 over 5. Question number 5, the answer is 2 over 5. So I hope you understood this some basic start from. If you continuously follow this video series, definitely you can work in the future your exam problems, right? So next question number 6. Limit x tends to 0. X tends to 0. Sine 4x into tan square 5x, tan square 5x over x square sine x. X square sine x. Find the answer. Limit question. If you direct substitute, check what happened. Sine naught naught, tan naught naught. Therefore numerator is naught, denominator is naught. One of the first meaningless pattern, right? Therefore there is no solution with direct application. Apply the x0. Therefore use some idea here. Your syllabus we have sine theta over theta, tan theta over theta. Therefore we rearrange this into that pattern. Here below x square. Therefore I divide to this one better if I use divide by up and down x square. Divide the numerator and denominator by the x square or x cube also. What happens if you divide x cube? Numerator, denominator, divide by x cube. Divide by x cube. Limit x tends to 0. Divide by x cube. Up and down. It's a multiplication, right? So sine 4x over, I take 1x here, show 1x here. X cube, x into x square. Divide 1x here, show the other x there. All multiplication of x into x square is x cube. So here tan square 5x over x square, right? I divide by x cube, 1x for here is shown, the other for other. What is below over? This divide by x cube, what happened? X square cancel, another x remaining. This gives you clearly, you can go to the answer step by step, the general form of sine theta over theta, right? So now how that? Sine 4x, therefore below 4x, tan 5x, then below 5x. So rearrange that form, the other step. So limit x tends to 0, sine 4x, okay, over below then 4x, sine 4x over 4x, the standard form. And here what? Tan 5x over 5x, completely square. Okay, tan 5x over 5x over sine x over x. So here I shown the standard form of the trigonometric limits for sine and tan. Now see, is this correct? Is this correct? Sine 4x available. Below 1x, not 4x. Therefore, is an additional term. But we using an additional term, try to remove that. If it's added, make subtract. If it's subtract, make addition. If it's multiple, make divide. If it's divide, make multiple. So in 4 division, therefore if I write a 4 here, okay, then 4 cancel. See here, tan square 5x, okay, and 25x square, 25x square, no 25, therefore x square, okay. Therefore remove the 25, multiple of 25 here, into 25, okay. Below is okay, right? Therefore the answer is 4 into sine 4 theta over 4 theta, like a sine theta over theta pattern. Answer is 1. That side 1 into 25. Below is 1. The answer is what? 29. So limit exists. We call limit exist. Straightly substitute, become a meaningless form. So in this case, answer 29, limit exist. Next question number 7. Limit x tends to 0. Tan square x plus tan square 3x plus tan square 5x over x square, complete tan. Same can be asked sine and tan, similar method. So how this? We directly apply what happened. Not, below not. So one of the meaningless or indeterminate form. Never use any other method. So here, if I divide separately, divide everything by x square, this completely common denominator, we show separately partial fraction, part fractions. So that is limit x tends to 0, tan square x below x square plus tan square 3x below x square. Okay, this is your first step. Divide every part by separate it by x square. Divide by x square each and every part of this fraction. Now we go to the theorem. Tan theta over theta, tan theta over theta, sin theta over theta form. Then like that. Limit x tends to 0. So I can write tan x over x completely square, right? How this one? Tan 3x. Then we need below 3x, okay? 3x, but this is separately as a square form, therefore I show as complete square. Here tan 5x over 5x completely square. Now check is it correct. Any additional pattern you have to remove it, eliminate those parts. This is okay. Here what? Tan square 3x is okay. There's a 9. There's a 9. Remove that 9. Multiply 9. Here what? Tan square 5 okay. Here 25. Remove that 25. With division, make it multiple. That's all. Write the answer. Tan theta over theta 1 plus 9 into tan theta over theta form. Answer is 1 plus 25 into 1. So the answer 34 is it? 24, 35. Answer limit x is to 35. So I am showing the brief method, right? If you are very clear, you can minimize the final students, final year students. They can, I think from here straight you can go to this part also, right? So I want to cover all of you, the juniors and as well as seniors. I am showing this complete solution. Next question number 8. Question number 8. Limit x tends to 0. X tends to 0. 4 minus 4 cos 2x. 4 minus 4 cos 2x over x tan x. So if you view my vectors, every vectors maximum 4 or 3 question I worked. That's applied maths, not if I want to read the problem also with paragraph type. But pure maths we can answer. See now the question 8 problem, now it's still the nearly half an hour. More we can work in pure maths. Same as you have to work with the exam style structure paper, you have to work quickly, you have to answer all the 10 questions within short period, maybe approximately 1 hour. You have to minimize the time. Less than 1 hour, then you are good to can go to the high achievement in the pure maths paper if you minimize the timing. Exam means timing. Okay, so the idea strictly applied x4 0. What happened x4 0 here? Cos naught 1. That means 4 minus 4 0. Below tan naught no. So naught over no chance. Straight substitution, one of the most question come the first meaningless form 0 over 0. Therefore use any other form. We have the sin theta over theta, nice answer for limit theorems, limit problems. Therefore I try to convert your double angle formula. You know what is cos 2x in terms of sine? What is cos 2x? 1 minus 2 sine square x, is it? Okay, cos 2x equal 1 minus 2 sine square x. Therefore, I want to change the cos 2 for sine. So, limit x tends to 0. I take the 4 and show it. Take the 4 out. 1 minus cos 2x over x tan x. Okay, so there is a limit x tends to 0 for what is 1 minus cos 2x, double angle formula, pure maths trigonometry, that is 2 sine square x, 2 sine square x over x tan x. Okay, now think a method how to work this to go the correct value. Here 4 times 2 is 8. Also if I divide by up and down by what? X value. X square value, divide by x square up and down, because we have the x square here, divide by x square up and down. So limit x tends to 0, 8 sine square x, then below I divide by x square up and down, numerator, denominator. So here 1x cancel, then 1 other x there, tan x over x. Okay. So it's the pattern, sin theta over theta form, tan theta over theta form. Okay, can I write this completely square? So write the limit 8 into sin theta over theta 1, below 1 tan theta over theta is 1, therefore answer is 8. Okay, limit exists. If a direct substitute, it comes one of this. Therefore, here's a limit. If you use it, this type of using trigonometric identities. Next question number 9. Problem 9. Limit x tends to 0, sin x over square root of x plus 2 minus square root 2. The first time I shown a irrational type problem. So everything miscellaneous in the final paper. You see many past days and past papers. So these other questions comes alternately, trigonometric part, algebraic part. Something is like irrational also. So what happened? X for 0. Numerator sin naught. What is below x for 0? Square root 2 minus square root 2, 0. 0 over 0, meaningless pattern. So think what the method. So I hope you complete this type of problem. Many questions you work with our ordinary theory class. So here the method first we use, but rationalize the denominator. Rationalize the denominator. That means remove the square root parts which is there below. Make the square root remove, vanished without the square root. So therefore, limit x tends to 0, sin x over x plus 2 square root minus square root 2. What the method of removing a square root form or rationalize the denominator? Use the conjugates. You know conjugates, multiple numerator, denominator by the conjugates of this denominator. That means multiple by what? X plus 2 square root plus square root 2. Okay. Also below x plus 2. So juniors, I hope you know the conjugates, right? Conjugates part comes continuously. Finally we have complex number, complex conjugate. There is algebraic conjugate, real conjugates. There we have the complex conjugates. Okay. So therefore limit x tends to 0. So sin x into x plus 2 square root plus square root 2. What is this? Wherever we use that conjugate pattern, it becomes a factorization form. A minus b, a plus b. A minus b, a plus b means what? A square minus b square. Therefore, this square minus this square. Okay, this square minus this square. That is x plus 2 minus 2, is it? Is the answer if you take consider this denominator. A minus b, a plus b. That is a square minus b square. Square root means square root vanishes. Look at this. So therefore limit x tends to 0, sin x. So what is below? Check what is below. 2 cancel x. This is the main part. We need always sin x over x, then problem solvable. So the remaining here what? The square root x plus 2 plus square root 2. Okay. Now complete the answer. Sin x over x1 into, put x4 not square root 2 plus square root 2. So what is that? 2 twice. 2 root 2 is it? 2 times square root 2 is the answer. Limit x is to that one. That's question number 9. Next question number 10. Next 10 problem. Sin x plus tan x. sin x plus tan x over 3x square plus sin 2x. Completely power 8. It's something different, the same simple question but different mode. Here you take x tends to 0. Question number 10, right? X tends to 0. Limit x tends to 0. So stop the video, pause the video, complete, you try on and check with me the answers. Don't copy and go, always don't copy and go. You have to try, this is correct or incorrect, no matter. You have to complete in your own knowledge, then you can check with the teachers the answers, correct scheme, marking scheme. Extensive. So what happens if I apply straight is 0? Side not, tan not, below x also not. So not over not, meaningless form. So it's power 8 also, none, meaningless. Therefore the method we use in trigonometric way, limit x tends to 0. Or divide up and down by x square, is it? Divide by x square or x, whatever. Divide by x then. Divide by x up and down, divide by x. Divide by x each and everything within big bracket, divide by x everything. So sin x over x plus tan x over x. Okay. I am divide by x is enough. I need x square, not necessary. X divide by x. Here what? 3x square divide by x, 1x cancel, 3x plus sin 2x over x, completely power is 8, okay, divide up and down by that. So therefore limit x tends to 0. So can I alter this? Or you can show another step. I will mark here. This is okay. This is okay. Here what? Sin 2x, therefore below 2x. Okay. So I put a 2, but that is wrong. I can't put a 2 additionally. If so, I want to remove it. So dividing 2, therefore multiple 2 here. Okay. Now do the rest. Write the answer. Sin x over x 1, tan x over x 1, 3 times 0 0. Here what? 2 times 1 to the power 8. See here 1 1 2, below also 2, 2 divided by 2 is 1. So 1 to the power 8. Simple question, very easy problem, right? But every type question you have to approach before the final paper, then only it's you need to think the hardness, softness of any questions. See next question number 10. That's I think 11th problem. Question number 11, limit x tends to 1 minus x over sin pi x, and the useful question, sin pi x, sin pi theta or pi x, here x tends to 1. So what happened? Direct apply. X tends to 1, 1 minus 1, 0. Put x for 1, sin pi, horizontal line, sin pi, sin not, sin pi also not over not, meaningless pattern. You can't evaluate this answer. Therefore use any other method, trigonometric idea. Okay, 1 minus x important, the limit x tends to 1. X tends to 1 or x minus 1 tends to 0. Okay, x tends to 1 or otherwise x minus 1, take the 1 that side, like think like that, x minus 1 tends to 0. Okay, see here, limit x tends to 1 minus x. Can I write this pi x, sin pi x, can I show this? Sin pi x minus something like that. If I take x out, pi, sin pi minus theta, sin pi minus theta, second quadrant, sin theta, sin pi minus theta is sin theta. Think like that. You can write this one, pi minus x, is it? Is it okay? Sine pi minus x is sine x. Sine pi minus x is sine x. Here 1 minus x. How that? Pi into 1 minus x. Check this. Check this form. Is it okay? Sine pi minus pi x. Write that. Sine pi minus pi x. Sine pi minus pi x, like a sine pi minus theta pattern. Sine pi minus theta, sine theta. Is it okay? Sine pi minus pi x. I'll write that pi minus pi x. That is sine pi x. That is sine pi x. Okay. Now if I rearrange the general form of the limit theorem, you can write this one. Sine, take the pi out, x minus 1. Okay. Then below we need what? Pi into x minus 1. Check that. Sine theta over theta. Sine theta over theta form. Sine theta over theta, is it? Sine angle below without the sine sin. Without sin remaining part. Now check whether it's correct. This 1 minus x comes here. 1 minus x. Is it okay? Sine pi minus x. Sine pi x. Okay. Here x minus 1. Actually 1 minus x. This x minus 1 there. Then you can take out. No? Therefore the additionally pi available. Additional part pi is available. Therefore I remove this like 1 over pi. The question is 1 minus x. Actually 1 minus x is the problem. Okay. 1 minus x, so sine pi minus pi x. Okay. So here 1 minus x, sine minus theta minus sine theta. Therefore there's a minus problem here, minus problem. So what is the answer? What is the answer? This one, sine theta over theta pattern 1 minus 1 over pi. Check that question. Minus 1 over pi, is it? Sine theta over theta form. Sine pi minus pi x, that is sine pi x. Okay. Pi x minus, I'll change it. Is it okay? Sine. So better. No, not need minus. No, there's no minus. We'll check that. No minus there. Take the pi out. 1 minus x. Then below 1 minus. Answer is okay. 1 over pi. Check will be 1 over pi, right? Sine 1 over pi. Answer is 1 over pi, right? Pi only the additional term, multiple there. Okay, next question. Question number 12. Limit x tends to minus 1. X tends to minus 1. 4 minus square root x square plus x plus 16 over x cube plus 1. I think a method when x tends to x approach to minus 1. X approach to minus 1, what's the answer? If you directly substitute for x minus 1, check whether it's become a meaningless form. Here plus 1, here minus 1, 0. Square root 16 is 4. 4 minus 4, 0. Power negative minus 1 power 3. So therefore the meaningless form 0 over 0 pattern. So what the method? Usually the rationalizing idea. First you remove the square root above numerator. Use the conjugates, multiple numerator, denominator by the conjugates. So limit x tends to minus 1, 4 minus square root x square plus x plus 16 over x cube plus 1, and then multiple up and down by the conjugates of numerator 4 plus, right? 4 plus square root of x square plus x plus 16 over 4 plus square root of x square plus x plus 16. Okay, then what happened? Limit x tends to a minus 1. If you put plus 1, is it okay? Plus 1, that is a straight answer, minus 1. So wherever we use the conjugate form, it becomes a factorization. A minus b, a plus b form, that is 16a square minus b square, right? 16 minus square root removed over x cube plus 1 and 4 plus square root of x square plus x plus 16. Okay. Now check what happened in the numerator. Limit x tends to minus 1. Okay, what happened now? 16 cancel. Minus x square minus x. Minus x square minus x. Can I take the minus x out? Take the minus x out. It becomes x plus 1. Is it? Minus x square minus x. Okay. Therefore, after obtaining such a x plus 1, you decide to factorize. What is a cube plus b cube factorization? A plus b, a square minus a, b plus b square. A cube plus b cube pattern, a minus a plus b one factor, a square minus a b plus b square other factor. Therefore, can I factorize this? X plus 1. And the next one, x square. If it's positive, say minus 1x, okay, plus 1. And the remaining here, 4 plus square root of x square plus x plus 16. Okay, check this. Okay, now see x plus 1 cancel, x plus 1 cancel. Now you can write the answer. Put x4 minus 1 and see. Put x4 minus 1 plus 1. Here put x4 minus 1, that is plus 1. 3, is it 3 here? 3. What happened there in the bracket? Other one, 4 plus. Put x4 minus 1 here. Square root 16, that is 4. Is it okay? The answer is what? 24. 1 over 24. 1 over 24 is the answer. So I work this question 12 problem. So contact with me this continuous YouTube limit series. I try to show many problems the other, all colorful exam style question. Keep in touch. Those newcomers, subscribe this, then you can continuously collect this my old video for advanced mathematics as juniors or seniors preparing for exam this year or next year, no matter. These are questions of this grade 12 lesson, definite problem in the every structure paper. 25 marks, simply you can collect it. So keep in touch with me, continuous video. Subscribe and press the bell sign. You will receive all automatically.